Hello students, I hope that you all would be fine. In this short tutorial, we are going to discuss mole. Mole is the SI unit of the amount of substance in chemistry. Okay, and it is represented by this symbol, and it is used for comparison of the amount of different substances or same substance. Okay, for example, we have a compound or element A. Let's suppose it's a substance A and a substance B. The one having greater number of moles will be in greater amount. For example, this A, here we have 3 moles of A and here we have 2 moles of B. So B will be in less amount as compared to A, okay? So this was a general idea of what is mole. But let's understand it with an intuitive explanation by comparing it with another unit we call dozen, okay? We know that whenever you go to a shop and ask the shopkeeper to provide you 1 dozen eggs, in other words, you are asking him or her to provide you 12 eggs, okay? So 1 dozen of any object equals 12 objects, okay? For example, 1 dozen eggs are 12 eggs, okay? Similarly, when you ask for 1 mole of things or 1 mole of a thing, in other words, you are asking for 6.02 multiplied by 10 raised to power 23 things. And if it was for x, if you ask for 1 mole of x, 1 mole of x equals 6.02 multiplied by 10 raised to power 23x. And this is a very large number, okay? If we write it instead of scientific notation, right now it is written in scientific notation, but if we write it in number form, then it would have 23 zeros after 6, so it is a very large number, okay? So that's why, since mole is counting the number of things, that's why mole is itself a counting unit, because it counts the number of things. Now let's proceed to study the concept of mole in chemistry itself. Now in chemistry, mole is used to express amount of substances like elements, compounds, ionic compounds, covalent compounds, etc. In chemistry, we see that any type of matter, any substance is made up of particles, right? And these particles may be ions, atoms, molecules, etc. And sorry, let's remove it. And these ions, atoms, molecules, they together combine to form substances, okay, different substances. 1 mole of a substance, 1 mole of any substance contains 6.02 multiplied by 10 raised to power 23 particles of that substance. And these are the particles which make that substance. For example, we have sodium element. in a lab situation you are asked to give 1 mole of sodium element or 1 mole of sodium atoms. Okay, how would you pick up 1 mole of sodium atoms or sodium element? In other words, you are asked to provide 6.02 multiplied by 10 raised to power 23 atoms of sodium. And since it is a very large number, these atoms should form a macroscopic sample which can be seen, which can be handled. Okay, it is found, and this is very important, it is found that 1 mole of any substance, 1 mole of any substance equals molecular weight, formula mass, or atomic weight of that substance. Now we have different kinds of substances in chemistry, like we have elements, like we have compounds, and compounds they may be covalent compounds, ionic compounds, and ionic compounds will have ions. And you know that in case of ions we have formula mass, formula units, formula weight. Okay, so for example we have NaCl, which is made up of ions. So and so NaC we have an NaCl sample, which is sodium chloride. Let's suppose we have a sodium chloride sample of 58.5 grams in laboratory. Okay, this is table salt. Okay, the normal salt we use in everyday life. So we have a sample of 58.5 grams for NaCl. In other words, this sample of NaCl is equal to 1 mole of NaCl, because 1 mole of any substance equals molecular weight, formula mass, atomic weight of that substance. And here NaCl is an ionic compound made up of ions. So here in this case the formula mass of this formula unit of NaCl is 58.5 grams. If you calculate, you can easily calculate, like I have calculated. I have put the 23 atomic weight of Na and 35.5 the atomic weight of chlorine, and we have calculated this as 58.5. So 58.5 is the formula weight of this NaCl formula unit. Okay, and since this is the formula weight of this NaCl sample expressed in grams, let me include one more thing. 1 mole of any substance equals molecular weight, formula mass, atomic weight of that substance expressed in grams. Expressed in okay, rub it. And here we see that I express the formula weight of NaCl in grams. So that formula weight of NaCl, or that amount of NaCl which is equal to formula weight of NaCl expressed in grams, contained 6.02 multiplied by 10 raised to power 23 formula units of NaCl. You can think of formula unit as a molecule, but it's not molecule. Okay, because ionic compounds exist in lattice form, and there are many ions distributed throughout the lattice in a forming a crystalline structure. Okay, so we calculate the simplest ratio between those ions and we get a formula unit. So that was it for today. Have a nice day.